Okay, so let's have this set of questions here. So for letter A, so what is the antiderivative of negative 3? And then for letter B, so what is the antiderivative of 15x squared? And then for letter C, what is the antiderivative of 30x raised to 5? Okay, so let's answer A, B, C first. So the antiderivative of negative 3 is equal to negative 3x plus c. So always remember this, that the antiderivative of a constant, you just put x here, or you just multiply it by x, indicated by this, okay? And then don't forget the plus c. So this is true for all constants. Now for letter B, so what is the antiderivative of 15x squared? So that is equal to, so coefficient be set aside here. And what is the antiderivative of x squared? So basically that is x cubed over 3. Now this is 3 because 2 plus 1 here. So that's why you have 3 here. Now, and remember, your index is also your denominator. Okay, so again, if let's say this is 1000, that means that your denominator is also 1000. Okay, but then for this question, you have x cubed over 3 and then plus c. So simplifying this, we can divide 15 and 3. That's why your final answer is 5x cubed plus c. Okay, and then let's go to letter C, which is similar with letter B. So again, for letter C, what is the antiderivative of 30x raised to 5? So again, we set aside the coefficient, and then we get the antiderivative of x raised to 5. So we got x raised to 6 over 6, and then plus c. So simplifying this, we'll get 5x raised to 6 plus c. Okay, that's letter C. And now let's have letter D. Now, letter D is a fraction, okay? But in integration, we don't have a specific quotient rule or even a product rule. So what do we need to do when you're given something like this? So we need to rewrite our question. So we need to remove the fraction by moving this x cubed towards the numerator. So this is our new question. So we have negative 2, and then now x is raised to negative 3. Okay, so answering this, so we set aside negative 2, and then what is the antiderivative of negative 3? So it's negative 2 because it's negative 3 plus 1. So if this is negative 2, this is also negative 2. So simplifying this, your answer is 1 over x squared plus c. You should always express your final answer in positive indices. Okay, so that is letter D. How about letter E? So for letter E, your question now, or our question now, is an expression. Okay, so we now have 12x raised to 5 minus 6x. So how do we get the antiderivative of this expression? So we basically need to get the antiderivative of each term, just like what I wrote here. Now, you don't have to write this in your workings. You can jump straight away in getting the antiderivative of each term. Okay, I just wrote it here just to show you guys that you should integrate each of the terms in an expression. So getting the antiderivative of this, so 12 here will be set aside here. And then what is the antiderivative of x raised to 5? So it's x raised to 6 over 6. And then for 6x, so again, you set aside 6. And then what is the antiderivative of x? So it's x squared over 2. And then plus c. So simplifying this to here, our final answer is 2x raised to 6 minus 3x squared plus c. Okay, and then let's continue on with another set of questions. Now, what if you're given something like this? what is the antiderivative of x squared minus 1 over x squared? Now, again, we don't have a quotient rule or even a product rule for integration. So what should we do with this question? So we should remove the fraction. So by doing that, let me rewrite this fraction like this. So x squared divided by x squared minus 1 over x squared. So simplifying this, you'll get 1, and then minus, and then rewriting this without any denominator, this 1 here becomes x raised to negative 2. And this is your new question. So you get you get the antiderivative of each of this. So the antiderivative of 1 is simply x. And then the antiderivative of x raised to negative 2 is x raised to negative 1 over negative 1. Again, this is negative 1 because negative 2 plus 1. Okay, and then plus c. So getting the final answer, so you have x plus 1 over x. Okay, take note that this is a negative times a negative. That's why this is now a positive or a plus. Okay, and then rewriting this in a positive index, so it's 1 over x plus c. So therefore, this is your final answer for letter L. And then our last example here. So we have x squared plus 1 over root of x. Okay, so again, we don't have quotient rule for integration. So what I'll do here is to remove the denominator. First, by rewriting root sign and making it a fraction index or raised to 1/2. And then what should I do next? So I will divide this with this and then 1 by the same denominator, of course. So what are you now? What do you have now? So we have x squared over x raised to 1/2 plus 1 over x raised to 1/2. So how did I get 3 over 2 here? So if you still remember in your, let's say, Sec 1 or Sec 2 maths, so whenever you have x raised to 5 divided by x squared, so what do? You subtract the exponent, so it becomes 5 minus 2. Therefore, your answer is x cubed. Now, same applies here, okay? So 2 minus 1/2 gives you 3 over 2. That's why you have 3 over 2 there. And then plus, okay, so rewriting this, so we put this in the numerator, so therefore it becomes raised to negative 1/2. Okay, so this is our new question. So we need to get the antiderivative of each. So the antiderivative of x raised to 3 halves or 3 over 2 is 5 over 2 over 5 over 2. Okay, why is this 5 over 2 again? So 3 over 2 plus 1. And then you'll get 5 over 2. Again, whatever your index is, that's also your denominator. Same with this one. So this is positive 1/2 now because it's negative 1/2 plus 1. And over 1/2 plus c. So what is your answer for this question? So if you have 5 over 2, how do you divide fractions again? So you get the reciprocal of the denominator and then proceed to multiplication. So getting the reciprocal of this, so you'll get 2 over 5 times x raised to 5 over 2, just like it. Okay, but then if you want to write it like this, it's still correct. Okay, how about for the next one? So you get the reciprocal of this, it becomes 2 over 1. So that's why this is 2x raised to 1/2 plus c. Okay, so this or your answers are correct. Okay, so it doesn't matter if you write it like this or this, it's still the same. Okay, now let's have a word problem related to indefinite integrals. So let's have number 2. This is also found in your AMATS book, okay, under indefinite integral. I think this is example number 3, okay. So let's have the question. So find the equation of the curve which passes through the point 2, 3 and for which the derivative of y is equal to 3x squared plus x. Now, we should understand that this given equation here is the gradient of the function right away. So this is the derivative of y. Now, what we're after here is to get the original equation before we derived it. So how do we undo a derivative? Or how do we go back to the original equation or function? Of course, we just apply integration in this question. That's how we get, or that's how we go back to the original equation. So for this one, so we get the derivative or antiderivative of 3x squared plus x. So solving this, so we will have 3, and then the antiderivative of x squared is x cubed over 3. And then the antiderivative of x is simply x squared over 2 plus c. So simplifying this, our final answer is x cubed plus x squared over 2 plus c. And that is the equation for the value of y. Okay, for the value of y. But then we are not yet finished. Okay, because look at c here. You cannot have a letter c in your equation. So how do we solve for the value of c? Since this curve here passes through the point 2, 3, so 2, 3 is part of the solution. Okay, so what do we do here? So given this, we just plug 2 in place of the x's and then 3 in place of y. So substituting them and solving for c, c is equal to -7. So what do we do? So we just plug it here in the equation. So therefore, the equation of the curve is y is equal to x cubed plus x squared over 2 minus 7. So this is your final answer. So this is the equation of the curve. And that is example number 2. Now let's go to the next example, number 3. Now in your books, this is example number 4 under indefinite integrals. Now listen carefully. Number 3. Given that the derivative of y is inversely proportional to x squared, and that y is equal to 1, and the derivative of y is equal to 3 when x is 3. Find the value of y when x is equal to 2 first. How do you write inverse proportion? So if you go back to your Sec 2 maths, so this is how you write inverse proportion. Y is inversely proportional to x. So given this question, so the derivative of y is inversely proportional to x squared, okay, from this. So first, how do we proceed with proportions? Basically, we need to find the constant first, or the value of k, given this, okay? So that the derivative of y is 3 when x is 3. So we just substitute it here in the equation. So this is 3 from here, and then k, and then x squared here is 3 squared. So therefore, if you solve this, k is equal to 27. So this is now your formula or your equation for your inverse proportion. Okay, next. The question here is asking us to find the value of y. But let me ask you, is this y? This is not y. This is the derivative of y. So how do we go back to the true value of y or to the true equation of y? So how do we reverse or undo a derivative? So basically we get the antiderivative of this, or we integrate 2x or 27 over x squared. Now going here, so let's find the value of y or the equation of y. So getting the antiderivative of 27 over x squared, so we need to rewrite this because we don't have any quotient rule. So instead of over x squared, so it becomes x raised to -2 and then times 27. So that's why this is our new question. So simplifying this and answering this, so 27 is set aside. Then what happens with x raised to -2? So this is -1 because -2 plus 1. And then again, whatever your index here is also your denominator. So finalizing this, y is equal to negative 27, okay, over x plus c. So this is your equation. But then, like our previous example, we cannot look for the value of y since we have letter c here. Now, how do we solve for c? Now, given there in the question that y is equal to 1 when x is equal to 3. So we're going to use those points. Okay, so let's plug here 3 and 1. Okay, so 1 is equal to negative 27 over 3 plus c. So solving for c is equal to 10. So c is equal to 10. So this is now our complete equation. And then from the final question itself, find the value of y when x is equal to 2. So when x is equal to 2, we just plug 2 here. Okay, and then therefore y is equal to negative 3.5. And that's it for number 3. All right, so now let's have our next integration rule. Now, okay, what if instead of just having 2x squared plus 1, this expression now is enclosed in a bracket, and then you have an exponent outside your bracket. Unlike before, we just had like this, so it's like 2x squared plus 2x. Okay, but what if there's an index now outside your brackets? So it's a different story, but it's not very far from the first thing that we have studied. So we have it here. So the antiderivative of ax plus b raised to n is equal to, okay, the same expression, and then n plus 1. Okay, but then instead of just writing here n plus 1, you need to consider the coefficient of x, which is a. So it becomes a times n plus 1, or whatever your index here, you multiply it with the coefficient of x. Now let's have letter a. So for letter a, so we have 2x squared plus 1 cubed. So this is 2x squared plus 1. Again, this is 4 because 3 plus 1 came from here. And then over, again, if this is 4, this is 4. But then you have 2 here. It came from the coefficient of x squared. So simplifying this, your answer is 2x squared plus 1 raised to 4 over 8 plus c. That's letter A. Now for letter B, so what is the antiderivative of 1 over 2x minus 1 squared? Again, since we don't have any quotient rule, I'll just rewrite our question. So it becomes 2x minus 1 raised to negative 2. That's it. Okay, so how do we answer this? So similar, so bring down the expression like this, and then negative 2 plus 1. That's why you have negative 1 here, and negative 1 here. And then this 2 came from the coefficient of x. So simplifying this, you'll get 1 over 2, or negative 2 times 2x minus 1 plus c.